Warm greetings, everyone. On behalf of W4W Foundation, constituted as a citizens collective, we welcome you to another session of Wednesdays for Water. The conversation today is on Water Pollution Series 6 on innovation and way forward in sustainable wastewater treatment. The objective of Wednesdays for Water is to engage in conversation with water experts, grassroots practitioners, policymakers, and youth to explore the complex intertwined issues associated with water and the possible solutions. It has extended since then to have more activities like the Friday Waters and the Monday Munching with Women for Water, besides organizing water workshops, water walk and talks, seminar, special courses, and conference panels to continue the water conversation in various possible ways. Please visit our website www.w4w.in for more details. We are running a water pollution series to bring our conversation focus on the problem of plastic and other wastes in our water bodies. Today's session is a part of the Wednesday series in collaboration with the Center for Global Affairs and Public Policy, shortly known as CGAP, as a part of the project Tackling Plastic Pollution in the Ganga Basin. The project aims to address the degradation of the mighty river through research expeditions at several regions, youth and community outreach program conducted all over the country, and water conversations with experts and policymakers. My name is Prashaka Mitra and I'm the facilitator for the session from W4W, and we have Priyanka Mukherjee to do the session moderation. Priyanka is currently a CSIR SRF and a PhD scholar with Dr. Mamta Mahapatra, CSIR IMMT, and Dr. Utpal Adhikari, NIT Durgapur. Her research interests are the synthesis of metal oxides, composites, and hybrids for application in arsenic detection via electrochemical techniques. Her work aims to develop a low-cost and multiple-use chip sensor to detect the presence of heavy metal ions, especially arsenic. I shall now hand over to Priyanka to take the session forward. Over to you, Priyanka.
Thank you, Prashaka, for a wonderful introduction to the session. Moving on to today's session, which is Innovation and Way Forward in Sustainable Wastewater Treatments. There are many ways water can become contaminated by natural disasters such as floods, hurricanes, and tornadoes, or by various man-made disasters and industrial pollutions. Sustainable treatment of the wastewater renders it reusable or otherwise known as recycled or reclaimed water and is a sustainable and economic practice. Wastewater treatment is beneficial for both small and large-scale industries as well as households, and the reused water can be utilized in numerous ways. However, considering the current situation, the translation of research from lab to industries is paramount. The effort has to move the research from lab to land and percolate into the grassroots. Further, research findings are inevitable in making ways for a sustainable living in a societal context. We need to work along these lines. Today's discussion focuses on a sustainable treatment of wastewater and translation of these research findings to technology levels. We have with us Dr. Trupti Das and Dr. Jyotsna Rani Jena as speakers. Dr. Trupti Das is a distinguished expert in the field of environmental waste monitoring and management with a specialized focus on the biological treatment of mine and municipal wastes. She is a senior principal scientist from CSR IMMT Bhubaneswar. Her expertise extends to the waste management and abatement, where she excels in studying the climate and health impacts of ambient air pollutants, specifically trace gases and aerosols. Dr. Trupti is known for her innovative research and development initiatives. In addition to her research endeavors, she is actively involved in academia, sharing her knowledge and experience by teaching master's and PhD students in both biological sciences and environmental science streams at ACSIR. Dr. Trupti's commitment to advancing environmental science and her dedication to education make her a valuable asset to both the research and academic communities. I would now request Dr. Trupti Das ma'am to please share her slides and enlighten today's session.
Thanks, Priyanka, for this introduction, and I'm really glad to be a part of this wonderful congregation. And yeah. So I'm just sharing my screen. I hope screen. Okay. So yeah, thank you for the introduction, and Priyanka. And thank you all, like Mansi and all the experienced women working for the cause of water here. I'm extremely privileged to be a part of this. So quickly I'll be saying about what the research community has been doing because the water problem here in our country is one of the most challenging issues. So although in the introduction we mentioned about our holy river Ganga, but apart from the holy rivers, Ganga, Yamuna, Saraswati, and Godavari, Krishna, Kaveri, name it, and across the country, all of the entire civilization was built across the mighty rivers. And what we did, unfortunately, as the with increasing population, industrialization, and the basically the when the treatment of the water, the wastewater was directly drained to the rivers were actually thought to be the source which can take the wastewater, because normally we felt that in a flowing river the waste components gets diluted. So that's how it kept on the process kept on building up, building up, and now we have ended up in a situation where from where we cannot go back. So we see that most of the water bodies, the stagnant water, the ponds, the canals, any water body across our country, when we travel and we look at the water bodies, the conditions are very unfortunate. Like most of the water bodies have been converted to nalas. It is a very very sad thing, and so government of India has been supporting various research programs through which in the labs we take up projects where we plan and execute experiments, and mostly these are all small scale experiments. Initially we start from 500 ml synthetic solutions, then we try to scale up to 1 liter, 5 liter, 10 liter. So here I would just because I my time scale is just 10 minutes. So I just wanted to just give a bird's eye view that what the research community is up to. And here in IMMT we were trying to develop various microbial processes to treat this wastewater. And wastewater is of like several kinds, like as Priyanka was she was summing it up, like it comes from various sources, from municipal sources, from industrial sources, from agricultural runoff, and several other sources. So all this water, and everywhere we are using, like today we live in a sea of chemicals, and we are using so much of chemicals which are actually the treatment processes are not very unfortunately in India most of the treatment processes are not very hardcore, and so these water which where the the biological oxygen demand of the water is really affected, impacted, and this kind of wastewater are landing to the water bodies, the flowing rivers and canals, etc. So what we did, you can see that there's a diverse group of microorganisms who have the capacity to convert this waste to wealth. And we can, like, there are processes where chemicals are used to treat the wastewater, but when we use chemicals we further degrade the quality, like although the processes are fast and more user friendly, but the quality of the water again goes down, because we are again adding some other harmful chemicals to address one problem. So we end up in some other. So that's the reason we try to take help of from nature. So this microbial diversity, these are the we try to work with the complex microorganisms. Like we try to make the process simple, in the sense, like we don't go for very I would say try to make the process more economical. Like we don't use very sophisticated methods, like we don't go for pure cultures and stuff. So we try to take a group of microorganisms, so that and we do different experiments in the lab to acclimatize these microorganisms to the conditions. Like we initially we work with the synthetic wastewaters, like we synthesize the wastewater in the lab and use these microorganisms to conduct their metabolic processes in the I mean in the water medium or the wastewater medium. And then we constantly monitor and see that how the microorganisms, they actually use the nutrients which are the pollutants actually in the water for their growth, for the growth of the microorganisms. That's also, these are the processes that we study. And I am showing that there are different group of bacteria, so I won't go to the details here. So yeah, so measurement of microbial diversity, I would say. So this is also a very important factor, because today, as science has advanced, to a quite a great extent, so it is very with minimal expenditure we can also understand what is the diversity in the water in our reactor system where we are doing these treatment processes. We understand the diversity, and then we try to enrich these microorganisms, these diverse microorganisms, through different scientific processes, so that it becomes very easy for us to get the wastewater treated. So we try to bring most of the contaminants to the normal level, so that they can be discharged in a proper way, proper fashion to the water bodies. So therefore the impact on the water bodies, on the flowing rivers or the canals, would be really less or low. So yeah, so here I think I have already spoken about this, and this is a very important. I hope my slides are moving. Hello.
Yes, it's moving. Yeah.
Yes.
Yeah. So yeah. So here we can see in this slide that almost this 2 million tons of sewage and other effluents drain into the walls water bodies on a daily basis. So this data are something which are really alarming for us. And then okay. So yeah. Yeah, so this is something like the total gray water footprint. So these are some information which I collected from different sources available in the internet, to show that how the most populated areas across the world are living in either water scarcity conditions, or the water is too polluted in these areas. So we do not have access to a very good, like, okay, so at homes probably we are filtering our waters and drinking, but we don't do it like when we are growing our plants, we're washing our clothes, we're doing gardening or whatever we are using. So we cannot filter every bit of water. So it is very important, like through the plants also the contaminants reach our body. So that's what I'm trying to say. It is very important to whenever any scientific planning is done, it is very important to access the intensity of the problem. That is the first thing. And the second thing is that we do a very strong planning, how to execute, what are the problems, how to execute. And we diversify also, like we try to dissect it into different parts. And after dissecting, like we try to work on different individual components. So that is how. And these are actually, I would say, very we go to a point which are actually extremely focused. So that is the reason the researchers, it is high time that the researchers need to join hands with the people who can take this work to the field. Normally what we are doing, we are working and we are bringing out good results, and these are only published. And since it is difficult for us to address the problem in the real industry, like during my research tenure, I have visited several industries who have a problem with the water, like dairy industries, fertilizer industries. But when we go there and we see the humongous amount of the water, wastewater that is being stored for processing and treatment, so it becomes mind-boggling thing for us, because we normally work in 5 liters, 10 liters, or 20 to the best 20-liter scale. The piloting a process needs huge manpower, a lot of money, and a lot of support, financial and other logistic supports, which becomes difficult. So I would say that okay, so looking at the problem, I would say that it is very important for us that now we should take the next step. Like when we were talking about river Ganges, I think the plastics are not the pollutants probably that are visible. And apart from the plastics, there are many invisible pollutants in the Ganges that is flowing, and which are very, very toxic as well. Like there are a lot of endocrine disruptors. These are because normally we in India we have seen that we consume medicines, and when the there are many hormones, antibiotics, and stuff, and when the expiry date, some for some medicines the expiry dates are and gone and stuff, or we are not using it, normally we keep throwing it, we just throw it. So most of these we don't treat those in proper manner. So most of these actually end up in the water bodies, and even these contaminants, even in ppb or ppt levels also can impair our metabolism. So a single change in a single enzyme in our body could trigger a lot of metabolic changes, and a lot of processes might be affected through that. So apart from the endocrine disruptors, there are various other contaminants like the nitrates, the phosphates, the COD. So these are all a lot of things, and microplastics now. So many other things apart from that, a lot of pathogenic bacteria and other things which have made our water body really, really and that's the because we are not treating the nutrients for the growth of algae. Like we can see a lot of eutrophication in our water bodies today. That's because we don't treat the like nitrate and phosphate, which act as the nutrients for the growth of the algae. So these are the major problems, I would say. And see, yeah, so this is a very classic picture. I think I have taken this from one of Jyotsna's presentation, because when we were walking together quite some time ago. So this is a lake from Bengaluru. So you can see the foams, the froth, it is from the lake, and this is because of some contaminant. So these are the problems. And yeah, so like I think I have already discussed about how we in a scientific level, as a researcher, how we try to address the issue and stuff. And now I think this is it from my side, and I would be happy to take more questions. And I think Jyotsna would be talking more about how we can take this forward to the next level. So if there is any question or anything, so this is yeah, this is some of our this is how we make the flow charts, and we plan our experiments, and we here we go to the different like different details, other details, like how other researchers across the world they have worked, what are the gap areas, and we what we do to fill up these gaps. And so this is how a research team across any part of the world works. So yeah, I will be happy to take more questions, because I thought this is more interactive session. So I didn't make it more like, I thought I will speak more rather than showing some slides. Yeah.
Thank you so much, ma'am, for enlightening us with your valuable insights on the research. We will be taking questions at the end of both the talks. I think that will be
Okay.
more enriching for our viewers.
Okay.
So moving on next, I'll be now introducing our next speaker for the session, which is Dr. Jyotsna Rani Jena. Dr. Jyotsna Rani Jena is a seasoned researcher with her extensive expertise in environmental microbiology and wastewater treatment. Holding a doctoral degree from the Academy of Scientific and Innovative Research, her research has been primarily centered on the biological nutrient removal from high-strength industrial effluent, showcasing her profound knowledge in biological wastewater treatment and management. Currently serving as an Associate Technology Transfer Officer in KIIT TBI TTO, an initiative of DBT, BIRSC, and Ministry of Science and Technology, Government of India, Dr. Jena is actively involved in facilitating the transfer of cutting-edge technologies from their nascent stages to the marketplace. Her role involves collaboration with academia, industry partners, and other stakeholders to bring about a positive transformation in the realm of technology transfer. I would now request Dr. Jyotsna Rani Jena to please share her slides and enlighten our viewers.
Thank you, Priyanka. Thank you so much. This is really a good session. I hope I'm audible and my slides are visible.
Yeah. Yes.
Okay. Ma'am has already discussed about the basic problems, but the problem is actually a step ahead because we have problem, we have solutions, but somehow we are losing the string that we are not able to solve the problems at the ground level of where the problem is actually happening. Like when we're talking about rivers being polluted, we have to treat the water in the point source itself, because river is not a thing to treat as a whole, because it's not a stagnant thing and everything. And also for the diversity, biodiversity, and aquatic plants and animals, it's always advisable to adhere to certain guidelines issued by CPCB and state pollution control boards. But we fail somewhere. I'm not saying that we are not doing up to we are not doing anything. We are doing certainly something, but the hour is this is the point where we need to connect all the researcher, all the magnificent researchers going in different institutions, different universities. So I think there is a gap area where we have to jump in and fill in. So that's how I decided to speak on this research to reality, because I have been on the both side of the cases. I have been a researcher also. So I have worked with industries also when I was working in CSR NCL. So we actively work with industries, those who come with their problems. And there we got to know how to interact with and how to design problem according to design your research problems according to the industrial need. So that's why I would design my talk, Research to Reality, Innovation and Way Forward in Industrial Wastewater Treatment. So currently, as I'm working in Technology Transfer Officer, I take this privilege to speak on how technology transfer, this is the initiative by NBA, National Biopharma Mission, by Department of Biotechnology, BIODAT, and they are pushing this as a project, in a project mode, to see how we can bridge the gap between institutions, academia, and the industry, because there are solutions, there are problems, but somehow we are not bridging the gap. So I'll not take much time because I have already started my timer. So to say it briefly, that we have basically three types of wastewater treatment processes: physical, chemical, and biological. So physical is mostly like cleaning, adsorption, like you must have heard about the activated carbon, and what you have in filter candles in your water filters. So those are all physical. And chemical is coagulation, flocculation, neutralization, precipitation. So this is a kind of process where you utilize chemical agents to precipitate the a certain amount, pollutants, and filter it out. So then you will have the sludges also. And third one is biological process. So biological process, as ma'am discussed very widely, activated sludge, biofilters, anaerobic digester, constructed wastelands, and many more to add. So there are biological agents like microorganisms, and in constructed wetlands, some plants, those who helps to remediate the pollutants. So I have worked for like 5 years in my PhD in activated sludge process when we utilize microorganisms to remediate phosphate, nitrate, as well as the carbonaceous material like BOD and COD very effectively. But unfortunately, I would like to say that we haven't transformed this amazing technology to any industry because we lacked that knowledge, we lacked that support. But I would show some examples where people are actually doing technology transfers to biological processes to industries also. So that is what people need to understand. Researchers needs to understand that if you have the potential in your technology, you need to think about what is the way forward. Of course, it is not possible without support of all the stakeholders. But at least we have to think in that way, so that if we are thinking in certain way, then solutions might appear also. So I would very crisply so that this is the lab scale processes we follow in our laboratories normally. All researchers in lab scale processes, when we are when we are talking about technology transfer or whole technology scenario, we can divide all the processes in different technology readiness level. So technology readiness level means, suppose you have an idea. So I can say that you are in a technology readiness level 1, and when you are proving it in a concept or proof of concept, then you are in technology transfer level 3. So when and it goes up to technology TRL 8, technology readiness level 8, when your technology is ready to deploy it. That means you are ready to deploy in a certain area where the problem is actually existing. You are solving that problem. So this is the case that there is a huge gap. In laboratory scale, we only go to maximum TRL 4, but we have to achieve TRL level 4, 8. There is a huge gap between that. So there are a lot of things coming up by Government of India, Government of Odisha as well to bridge that gap. There are a lot of fundings and supports coming from forming startups, forming spin-offs and projects, and there are a lot of supports coming up these days to bridge these gaps. But yes, this is the problem actually happens when we go for implementing, because we, as ma'am said that we in laboratory we usually make this system very successful in lab scale, bench scale in 2000 liter and in 5000 liter maximum. But when we see the actual scenario, these are few cases where actual scenario. One is the first one is one STP in Cuttack. This is 16,000 meter cube per day. This is processing this amount of wastewater. And this is a Hindustan Zinc Udaipur's waste treatment plant, which is processing 55 MLD per MLD, and this is Tata Steel, and it's 180 MLD. So any industrial level wastewater treatment system you take, you will not be seeing like small scale industry, even if not pilot scale. Well, they will support you in establishing a pilot scale and give the proof that okay, your system is working. But when they go for the larger scale and the actual implementation, they have to go for the larger scale because the demand is high and the load is also high. So there is the gap. So I have listed some challenges in implementation. Scale up complexity, as I have already mentioned. Operational cost and energy requirement. When we operate in lab scale, we actually don't have that clarity. When we going to implement this system in real scale or the field scale, how it is going to energy intensive or cost intensive. So that is difficult to forecast when you are running a 200 liter system and you will upscale it to 600 mld. And second is reliability and robustness. And when we are talking about microorganisms, so they are very, very unpredictable, I must say, because they are live microorganisms, and they respond very actively to weather, to the temperature, to type of wastewater coming into. So there is a question that what you are doing in laboratory in a very controlled way, so whether it will be reliable, robust, be proved in lab scale or not, I mean real scale or not. And next is adaptability to site specific factors. Whenever you are like whether you are proposing a biological wastewater treatment or any other wastewater kind treatment system, whether it will be adaptable to whatever specific situation they have, because in many industry, all the industries, all the municipal wastewater will have different components. So whether it will be addressing to that particular kind of wastewater or not, like it will be responding to those kind of contaminant or not. Even suppose we have developed the microorganisms to address the phosphate. Okay, phosphate, there is phosphate, so that can address the phosphate, but there is also ammonia, there is also some other components which might harm the microorganisms. So what about that? So that is one more thing we need to think as a researcher. And another is long term stability and performance. So when we have a lab scale system, we usually go for a our project is mostly 3 years, so we have to have our R&D for two maximum 2.5 years, then we have to wrap up. So, but when you are proposing to an industry as a solution, so you have to show long-term data that okay, this is running and this is running in all parameters and every kind of situation. And regulatory compliances is one more thing. Suppose you have using some kind of microorganisms, as I said. So you have to have when you are going for a commercialization, you need to have the approval from National Biodiversity Authority. Otherwise, you cannot use microorganisms as the your buy property. So that is one thing. Most of the researchers are not aware about that, the regulatory compliances and community acceptance. So when you are implementing those kind of thing in a community, and one that is also a thing that we don't most of the wastewater treatment system in closed system, I mean closed premises, but we need to involve also the community. For that, we need to get the community also get aware about that, and so that they will be accepting those solutions that okay, this is for our betterment. And there are technology transfer barriers. I would show this technology transfer barriers and what are the cases and what can be the barriers technology transfer, like when we are going for a technology transfer from your lab to a certain entity like industries or any other form, I mean stakeholders. And the important thing is that integration with existing infrastructure, because currently lot of industries are having their wastewater treatment system itself, but the whatever suggest, suppose they are having a new problem or new entity to address, and they come to you and you are proposing a solution, and for that solution they have to redesign their whole system, so they will be definitely reluctant. So you have to have think that whether my system or whatever solution I am proposing, can it be retrofitted to the existing solution? So they will be more interested. So we have to think about that also. So and next is monitoring and controlling challenge, because when you are having a small scale system, it is very easy to monitor and see what is going on, what is going wrong. But in large scale, so we have to develop a system, and things are coming up like modeling, and AI is also stepping in to help the scientists to target and to monitor all these systems parameters also. And as I said, environmental impact assessment of your technology is very, very important, because now currently everybody is asking how green is your technology. Like every company has to submit a ESG report, environment sustainability governance report, to government. So there you have to show that how green is your technology and how the carbon footprint is being reduced. Is it consuming less electricity? Is it consuming less carbon footprint in whole? And is it emitting any kind of carbon dioxide? So all these have to be mentioned. And if it is your technology is green, then greener than the other technology, then it has the potential to go to the market easily than the other one. And community involvement, as I have already mentioned. So this is the technology transfer initiative. Like I said, suppose you have doing a research, I would suggest before taking up a research project, you need to have right there, you need to have to consult industries and to go through the market study that what is the problem. Suppose there are 1,000 solutions residing there, so you don't need to invest another once a year in that project or that solution. So suppose find out the problem which is relevant to certain industry. then it will be easier for you to transfer the technology to the industry. So there also you will have the opportunity to partner with that particular industry also. So then comes the disclosure. So you have to disclose your technology to the technology transfer office. Then they will evaluate. If you haven't evaluated, then they will evaluate preliminarily that whether your technology is commercially viable or not. If not, then again go to research and find out a suitable topic which is market commercially viable. There is 100 hammers in the market, so you need not invent another or make another hammer. So you need to see what is the market requirement. Okay, so then if there is commercial viability, then the need of our need of the industries, then yes, go for that. Then ownership and assignment, and this ownership and assignment comes when you have protected your technology through IP, intellectual property. This is very, very important. When we are in our, I was a researcher, uh, that was a saying in CESA mostly, publish and perish. Then it comes patent and perish. I would say if only you are also only you are patenting, that also not going to suffice, because even if you are have a patent of your product and if you are not trying for transfer of your technology, then also your technology is anyway going to perish. So that is first thing, that protect your technology. So that is one mistake we did, because what I was saying, that we have a very wonderful system working for phosphate and nitrate and also carbon, but we went for publication directly. We could have go for a patent, provisional patent at least. Then we had the protection of that technology with us. No one will to take the product if nobody has the guardian or nobody owns that technology. So someone will come that okay, I have the technology, or there will be a issue of that ownership. So company will always go for a patent protected technology. So then the commercialization plan. So we can you can go for a startup formation of your own. I would show one example where in NCL, one startup is spinned off from a technology, or identifying licensor. That is a second thing. That okay, I don't want to form a company. I'm all into research, but I have a technology which will be helpful for those kind of certain industries. Then the technology transfer office will find out those particular industries and pitch your technology to those industries, so that if they got interested, they will out license, or they will take the license of your technology. The licensing is like different kind of licensing. It's exclusive licensing, limited exclusive licensing, and non-exclusive licensing. If you are having a non-exclusive licensing, so you can license your technology to different companies. Company A can take your license, company B can also take your license. But if you are going for a limited exclusive license, like limited is like geographical limitation. Suppose you are giving rights of your technology to a certain company to operate in India, but and you are giving company B your rights to operate in other country. So that is a limited licensing. And another one is exclusive licensing. So you are selling your license or technology to a company which is going to have the ownership exclusively on the proprietary of your technology. So that is one. And then commercialization, revenue generation, management, and all those things, monetary factor will come. So since time is already 10 past 10 minutes, so I will not go into that. So what are the approaches? I have already discussed when I'm discussing the problems, but I would read out it only to make it more clear. Pilot studies is very important, and process optimization, depending on various factors. And in a large scale, life cycle cost analysis, continuous monitoring and maintenance, community engagement programs, regulatory alignment, capacity building, capacity building of about the technology transfer, about the IP, and about the implementing what you are implementing the problem, I mean solutions also. And flexible design concept, as I mentioned about the retrofitting of your technology to the existing system of the company. And collaborative partnership will help you identify the problems of that particular company or industry, so that you can work on a given problem and have a solutions to that. And then environmental impact assessment. with that, I would want to show that this is one Vivira Process Technology Private Limited. It is a spin-off from a scientist from NCL Pune, which is being implemented in various industries. And this is a physical process, physico-chemical process. So this treat numerous pollutants like sulfate and phosphate and COD and many things. And this one is very very important because we are talking women in water. So this woman is Dr. Shan Raj Chaudhary from Mizoram University. So she is being awarded for his technology microbial biofilm reactor, with which she converts wastewater, dairy wastewater into biofertilizer as well as treat that wastewater. So we are working with her very closely, and it's my pleasure to say that our office has already transferred his technology to two industries. So yes, women as from industries and from northeastern states also leading the tech transfer arena in wastewater treatment. So it's a really proud moment for us. So with this, I conclude my talk. Thank you. Thank you, everyone.
Thank you, Dr. Jyotsna
Please
Rani Jena,
close
for
your
a
PPT.
wonderful talk.
Thank you. I would love
Please
to
close
have
your PPT. Yeah,
questions.
thanks. Jyotsna, may I request to please close your PPT?
Yes, yes, I'm sorry.
And may I invite Priyanka to please take the discussion forward? Thank you so much.
Thank you, ma'am. And it was a very wonderful and insightful session, both from Trupti ma'am and Dr. Jyotsna Rani Jena. From Trupti ma'am, we got to know what are the laboratory measures that we are taking for treating the wastewater and converting it into a sustainable process. And as researchers or people working in the laboratory, we always have this basic question in our minds that how can we transfer? How can we transfer the research, translate the research from lab to technology scale? And this has been wonderfully answered by Jyotsna Rani Jena's slides, where I was like glued to the entire presentation and almost all my questions are answered. It was a vivid, in-depthful and self-explanatory talk. Both Trupti ma'am and Jyotsna Rani Jena, I, on the behalf of W4W, thank and extend my gratitude for this wonderful session. So,
Thanks,
moving
Priyanka.
on to the
It is
question.
a pleasure. Yeah, thanks, Priyanka, and it's really a pleasure. And I was also, Joshna's slides were very articulative and great learning thing for me as well. So thanks, Joshna, for the nice presentation.
Thank you, ma'am.
Yeah, so I would just quickly take down one or two questions first. My question to Trupti ma'am is, ma'am, like this sewage and wastewater is generated on like millions and millions acres of like waters and land mixed, like on the interfaces also. So what are the little steps that, very basic steps that we can inculcate in our household so that we can at least reduce it on the ground, on the grassroots levels? Because I believe that if it is source approximation, if we can at least minimize it at the source, then we can somewhere level down this huge wastewater generation.
Yeah, Priyanka, actually, here I would say that we would need the intervention of policymakers, because our households previously were designed in such a way, like we had soap pits and other things. So where the soil itself acted as a filter, like Joshna was showing in one of her slides, that the physical separation. So, but now when we moved into metropolis mega cities, and because I feel that because a generation prior to us, they always were moving towards urbanization, moving towards cities. But now, due to proper I mean, not proper planning, like especially when it comes to the treatment of the humongous, quintals of wastewater that we are generating through different processes. So our cities have become very unlivable, I would say. And of course, apart from the water, there are other issues as well. But water is a very, very important thing. Like in one of the, I would say, one of the conferences long ago, it was not a conference, probably we had gone to defend a project meet of DST, Department of Science and Technology. I heard one of the senior professors saying that, how many of you have seen a cow drink filtered water? So right, so there itself, like we, this is what is a big thing for us. Like it's not that water, we I mean just we are having access to filtered water or good quality water. So we also have to ensure that the environment in which we are living in has a good quality water as well. Okay, so coming to your point, like what we need to do to, mm, uh, in an individual level, what we need to do to address the problem. So it is a very, I would say, difficult question. Like in an individual level, yeah, there are definitely processes available, like different treatment processes which can be taken up by communities, like a particular housing community. So like Jyotsna was explaining, like it is very important, like each housing community or each community where we are staying, there has to be rules that, okay, so this much of things, or this water before being discharged. Normally what our sewage systems are connected to the sewage line, and the sewage line goes and ends up in a city. The sewage line, different sewage lines are interconnected, and they go and end up in some treatment plant that is flawed, that is not properly operational. So like I think I would say we need to make people more aware about it, and I think we need at the doors of the policymakers that we need to invest money in these sewage treatment plants, and we need to have very stringent rules to see that, okay, whatever these plants are operational and the treatment processes are happening properly. And like the government, the academia, the industry, they're all joining hands and taking this problem as a very, very serious problem. So this is what would be my,
I would like to add
answer to
a
you.
few
Yeah.
points to that. In Europe, they have two different lines for sewage and normal gray wastewater. Like for solid waste, human waste, so they have different sewage. So currently, we don't have that plan. Even if we have, people are working in research. I know that people are working on, and also STPs are also there. I mean, also being established in Odisha also, but that is the end solution. If we are planning to incorporate those in households, and also one thing is that urine separation is a very, very pertinent issue, because urine is contributing phosphate and night ammonia to the sewage wastewater. Okay, so if that can be separated, think about the whole India, how much phosphate and nitrate you can separate. But that is a big, big, talking about humongous country as a India, so that needs a very, very large steps and policy changes. That is a very big thing. But to talk about individual, what you asked, I think we need to think about installing solutions or commodes specifically, which might have a vacuum, might need less water. So those kind of things needs to be promoted. We don't also many people also don't know that those kind of solutions also there, because in many airports also you say that, okay, that's a very minimal air, water is being utilized, and some vacuum is used also. So that it can that kind of solution can propagate into households also. So that is going to make a huge difference.
Thank you so much for your wonderful answers to my question. And so moving on next, yes, I have a question for Dr. Jyotsna Rani Jena. Uh, you had already elaborated on all the little questions that I had in my mind, but despite that, I would like to know that how do we know as researchers that our product is market ready, like it's on the level, yeah.
Yes, that is actually, I would say, a very crisp answer to that. When we write a proposal, so what we do as a researcher, we go for studying a lot of researchers, I mean, research articles and whatever available in PubMed and Google articles, whatever it is there. So I would also suggest to read patent literature also. So what are the patents available currently? Because people are not I mean US patents, not only Indian patents, also US patents, because US in normally in US and other countries, many industries are working very very closely with institutions you name it, they have their technology transfer very well established.
True.
So they are working very closely with all the universities. So if you find out any recent publications, you will see that what is the demand in market, and also connected with your suppose if you are working in minerals, then connected with your groups, and also LinkedIn groups, those were discussing recent problems. So that we are mostly glued into Instagram, but it's as a researcher I would suggest to communicate with people, those who are talking about the problem, like we are talking here. So that is a very very good initiative to go to YouTube also. So I really commend that as a initiative, because people go there and see things. So you also have to be connected with right people and right groups to know about the problems, because as a researcher we don't have access to a lot of industry and also conferences, and it is also the responsibility of the head of the institutions to bring out industries and sit together and discuss what is the problem, say us, and we will give you the solution. Yes.
Thank you so much, Dr. Jyotsna Rani Jena. So now I would take questions from our chat box. First, we have Mansima. Would you like to ask your question from the box?
Yes, maybe. Thank you so much, Priyanka, and thanks, Trupti and Jyotsna, for the wonderful talk. Very short and crisp, as we would like it to be. My question is to all the scientists, and recently we had a session on paying a tribute to scientists. When you do these serious experiments, when there are so many experiments done, and Jyotsna was also trying to explain, Trupti, you also explained. For younger scientists, I mean, I don't have a subject related question actually, but the first question is more about the upscaling of the project. And many young scientists give up their even patents and give up their experiments after their project is over and publication is done. What kind of professional challenges they face in upscaling it? And that's my first question. And that probably, Jyotsna, you can elaborate from your own life experience. My second question is to you, Trupti, and it's on the three kinds of wastewater which we are talking about. And I'm just taking from your presentation actually when you showcase all the three waste: domestic waste, municipal waste, and industrial waste. So when you people are working on the laboratory, I just need to understand in the urban context which waste water you are considering to be more critical now when we talk when they come together, but I'm sure you have managed to find out a way of segregating, is now more serious in terms of getting solutions. Upscaling is completely different, but because I get very different vibes from the common practitioners and policymakers, but I need to hear from the scientists. Thank you so much.
Okay, so I would take the first question. You rightly pointed out that even if people have patent, there is a maintenance fee for that. So once a project is over, people used to lose the interest with that patent, and after some time, it's anyway patent is for valid for 20 years. In between also people give up on that patent, because if that doesn't, that is what you need. Like I can have a patent on any thing which is a little bit having a kind of little bit innovation to that. But if it is very much relevant to market, then I can market it. If it is not generating revenue for it me, then I would definitely not going to have invest any money on that. So my fasting, that is a very very slippery way to walk through, but that is the way we have to follow. Because if I feel that yes, this is a problem solving solution, then and for that I have to have the basic research done, and that is why collaborative research are that much important. And currently government is also pushing the collaborative research. So take all the stakeholders with you when you are designing the solution itself, so that you don't self your problem solution in a lab, or even if having a patent. If you are having all the stakeholders at same table when you're designing your solution or designing your project, then you will have very easy access to market.
You.
Okay. So, Mansi, yeah, so coming to your question, like which which wastewater you want to know that which one is the most critical. Here, I would say that each wastewater, like when it comes from household, like when it comes from industry, all these wastewater are critical in their own ways. Like they do different things to different like for example, the normally the wastewater which comes from the different houses, so they have a lot of nutrients in them, like nitrate, phosphate. So these are the different nutrients which help the water hyacinth to proliferate in the water bodies. So when the hyacinth spreads in the water bodies, the water becomes the diversity in the water body, dies down with time. So that water body becomes a dead body actually. So that is a humongous problem. Like if you remember when we were growing up as children and we used to travel, we used to see clean water, like especially small lakes, the ponds and stuff. So the water was still good. Even the canals were quite good. I mean, I remember, I mean, during my visits to my ancestral homes, we used to plunge into the water and had a lot of fun. But now I don't think, I mean, it is possible because it has a lot of contaminants in it. And then, for personally, I feel that the industrial wastewater, especially the water which is coming from the pharmaceutical industries, are too dangerous. Like they have traces of different contaminants which are properly not monitored properly. So we know there are issues in our country. So I think we need to discuss more on these aspects, like the pharmaceutical, the industrial components have to be very strictly monitored. As I said, the endocrine disrupting chemicals, these are hormonal tablets and stuff. So these are very very dangerous. Like we must understand that they can do colossal, I would say, harm to our growing population. So it is very important for us to be aware and do our bits, or maybe write articles. And as researchers, like, okay, we do take up projects. Like I have seen my colleagues, not only in India, also abroad, they are working on several different aspects, how to treat the wastewater in small scales as well. Like as Priyanka was saying, it is very important. Like if individually also, every house has a small treatment plant, then it would be really wonderful. But I think we have a long way to go when it comes to the segregating the wastewater, understanding the water, and understanding the dearth of the problem that awaits our next generation. So we have to be really really careful.
Thank you. Yeah.
Thank you so much, ma'am, for your answer.
Yeah.
Uh, I would not now like to take another question we have in our chat box. Shramana Mukherjee, ma'am, would you like to ask your question from the chat box?
Hi, I think it's okay if you go ahead and ask on my behalf.
Okay, sure. I'll go ahead with the question. Shamana Mukherjee ma'am says, very interesting talk highlighting such relevant problems of today. She has a question. Can we incorporate these technologies in city building processes such as in smart cities? How will they impact, help the local community in such cities? If any one of you would like to answer this question, please.
Yeah, I think Jyotsna also can speak on this. Personally, I feel it has to be an integral part of any city building process or all the smart cities. Like the first and foremost step of the smart cities should be, high rising, beautiful buildings that accommodate a lot of humans, Homo sapiens like us, but should be more on the environment that we are living in. Like we cannot exist without good water, good air. So it is not possible. So we have to be more vigilant about creating good environment rather than creating just good buildings. So maybe this is a very bitter truth, but this or just the road networks, I would say. So we need to, I think the paradigm shift is very very important here. We need to think along these lines. We cannot ignore these things anymore. So this is my, very personal perspective, but I keep thinking on this because as we read more and be more aware about the problem, so that actually gives a very puts a very perpetual pain inside the body and the mind. So it's very important that the smart city people need to think about this in a really really I would say prioritize this in the smart city components.
And it's doable too. I think it's doable too, because all the high-rise buildings is having lot of space for playground and all those amenities, and a small treatment system can be very very useful, and it also reduce the load on the final treatment system. So that has to, people are waking up, I think, because in recent past we are most obsessed with the concrete roads, but now we realize that it is not percolating the water, so they are now switching to the pavements. So rightly, I think, I also hope that they will smell the coffee and accept the solutions and implement it. And I think it should be also a compliance, is that if you are not having a at least a preliminary treatment system, then you are not going to get the permission. So then this will be like a very very good initiative. Yeah.
Thank you so much for getting to this question. Do we have any other questions from the live audience that we have right now?
I think
Yeah,
Priyanka. Oh, sorry, Mamta, go ahead. Huh?
yeah, thank you. So I have a very small questions to Jyotsna, Dr. Jyotsna, that this is the era of tech safe. So many rural people, they have the technology, but they are not being highlighted because they don't know how to make their technology ready, or their technology for the society. Maybe in many women, they do many home remedies, so, which is mostly bio-based, micro-based. This is already available in the India. So, what step, being a scientist or being a researcher or being a technologist, what step you could take so that these people can be a part of our journey, or they can also be like showcase their technology. So,
Uh, Saying that, ma'am, I
what
would
kind of
first
step
like,
you can take?
yes, ma'am. First thing is that I would like to clarify one thing, that if you want to have a patent of a technology, so there has to be three characteristics. One is non-obviousness, some inventive steps, and market benefits. So when I'm saying non-obviousness, that means the solution could not be very obvious. What you were saying, ma'am, normally what people are practicing in rural areas, so they are. I'm not denying that there might be some innovation existing there, Okay, so but when people are normally whatever practice in rural area, so that might be a very normal processes or very known processes. So for that, yes, we cannot go for a patent and all those things, but we can highlight them on this platform. Like people are highlighted for converting barren lands to jungle, so that is a very normal thing. Like putting plants, planting and creating a jungle is a very normal or very known thing, very obvious thing. But we have celebrated them and we have inspired millions to follow those paths. So for in that way, I would say they need the fame, if not the technology, the conventional technology transfer way. Because and even if there is some inventiveness or some kind of innovation they are actually having, then there are many steps are being taken. Currently by state of Odisha is having a that kind of vehicle is running through cities to cities, which is showing that startup Rath, that people are who are connected students, all the kind of school children also being associated with those kind of activities. So I hope with these kind of activities people will get more connected to these kind of ecosystems that we are talking about. But if they are not in that kind of innovativeness, or something is very obvious and they are practicing it religiously, so it is our duty to bring them up and to portray them as an ideal figure, that okay, see, even if they are not having those kind of technologies, those kind of facilities, still they are contributing to a certain cause. So that we can do and amplify that and inspire people to follow that. That is what I can say. If I think I have answered your question, Sam. If not, please tell me.
Yeah, actually, we always talk that we should go lab to land, but in water case, we should take land to lab. Whatever land practices are there, we can take to lab and see, validate for them, and maybe we can go for a big technology. Thank you. Yeah.
Thank you, ma'am.
Thank you so much. If we have any other questions, Taranuma, would you like to add something to the session, please?
No, I think it was a wonderful discussion. In fact, Mamta sort of brought it very clearly that as in scientific research, we invariably go with the classical theory approach. We don't take a grounded theory approach. So we first of all perceive that we know everything what the problem is. So we then prepare our own design and then we want to put it in the market and we want to impose it on the market. Obviously, people are not going to accept it. Why is it that we have those 4 P's of marketing and we talk about, you need to really look at the product, you should design it aligned to what is, and I think Mamta put it beautifully when she said land to lab and not lab to land. So till such time that the scientists don't start doing a need assessment before really. So हमारे यहाँ जब research PhD, when we approach PhD also, we approach it, okay, submit your concept note. What is your research question? Huh? What is your problem statement? What is your research question? I think problem statement in itself is the toughest thing to define, and researchers should definitely spend a lot of time, even if they're looking at designing a water treatment plant to address a problem like, I would say, arsenic removal. They should go to the field and see what the problem is about, huh? That is it just arsenic, or that water has other kinds of contamination also? Can the design be more inclusive of all kinds of contamination? Or can we engage with industries and we can say them that you should have wastewater streams so that not everything ends up together in the wastewater? A lot of criteria are there before really coming to a problem statement. But invariably, we are in a rush to define the problem statement without really understanding the core problem. And I think very strongly it emerged in this session also. All of us feel the same. The second thing that I see and I'm really worried about is that now we are promoting a lot like wastewater reuse in agriculture. And if we are not treating the water to the agriculture standards and just pretending that the water is ready for use in agriculture, we are going to fall into major problem with regard to wastewater reuse, because The moment the contamination, I have seen it in Kanpur, from the tanneries, from the CETP, the water goes, and we have tested some of the samples, in fact, in Lucknow, in and we have realized that that has chromium contamination already in the food chain. So, if we are promoting something like reuse of wastewater without bothering about that, it is going to be catastrophic. Even further, it is going uh, to the problem. And last, I think Trupti ma'am talked about the medicine disposal of medicines, and I don't know whether all of you remember there was a lot of discussion on superbug. So superbug is all about, how, because we have been disposing indiscriminately medicines into the water, that we people have started becoming resistant to antibiotics. Huh? So how that problem has developed, and but I still don't see much talk on this. I don't know whether you people in your respective cities have heard about it. That where do we dispose medicines? Suppose the medicine expires in my house, where do people go? Do RWAs have a place, common place where we can go and dispose that, or is there a common location even within your city where we are promoting that? Just as we wanted to get rid of polio, or get rid of, even for COVID, we had so much of publicity on the social media, on television. Can we also establish something like this and say that, okay, go throw your medicine there and don't throw it anywhere else? Huh? So we are still lacking a lot. I still feel water and wastewater even further lower actually falls in the priority of the decision makers as well. But thank you, amazing session. Always great learning whenever I'm able to join. It's awesome. Thank you very much, all of you.
Thank you for having us,
Thank you,
ma'am.
ma'am, for thank you, ma'am, for wonderfully adding to these sessions. Very rightly pointed out whatever you had to highlight regarding the disposal of medicines and other very crucial questions. So yeah, water is indeed a very vast topic of research, and there are a lot of work still going on from lab to laboratories and to industries. And like we hope that someday we'll be able to find some solution to this massive problem that we are catering right now. So, yes, now I would like Proshaka to please conclude the session by saying,
Thanks a lot for the enlightening session. Thanks to all the participants here on Zoom and on YouTube who make our water conversations. We thank you for your support and encouragement to make these conversations meaningful. You may reach out to us at www.w4w.in. We will continue with Wednesday sessions in the Wednesdays to come. Next week, the Wednesdays for Water session is on 31st Jan 2024 at 5 p.m. IST. Do join us for an online talk on the experience of the open elective conducted at NID on water matters. The link to join the session is given in the chat box. This Friday, 26 Jan, we invite you to our Water Arts of Friday Waters on water museums and the role of the arts at 4 p.m. IST. The link to join is also given in the chat box. And we shall continue doing the Monday Munching with Women for Water. We are also gearing up for a water fest to celebrate 250 water conversations. More info on it is coming soon. Do keep checking our social media accounts and websites for regular updates. Thank you to all of you. Take care of yourself. Bye.